This is Algebra 1, Lesson 18b, addition of like terms. In the last video, we learned what like terms are. They're going to have the same variables, and they're going to be written in the same way or in equivalent forms so that they have the same value. So this is the expression that we looked at in the last video. Okay, so we're going to start with that. Now, if I want us to pretend if this right here were the answer, okay, to a problem where you use the distributive property, what was the original problem? Okay, you remember distributive property, a little bit of a reminder example over here. If you had something like this and you use the distributive property, you would double everything in the parentheses and you would have 2x plus 6 is equal to 2 times the quantity x plus 3. That's your reminder. Here, let's pretend we're starting with the answer. Could you go back and tell me what the original problem was? What number could you have been multiplying by out here to where after you multiplied it, you ended up with this answer? So what do all of these have in common? Do you see that? Let's look. Let's even just look at the variables. Okay, for this example. Don't they all have the XMP, even though it's in a different order? So let's take out the XMP and let's see what we would have had left on the inside. Okay, so that XMP is missing this 4. So that when I multiply this times this, I would get 4 XMP, right? All right, what is this term missing? Well, if you multiply the XMP by something, you would get this back. What would we be missing? Well, we would be missing that too, wouldn't we? And on this term, we've got the XMP. When we multiply it by something, we get this term, okay? What would that term have to be? Well, it would have to be a 6. Now, for this particular answer, or for this problem, they do all, some of you may be thinking, well, but look, they have some numbers in common. Those are all divisible by 2. But I just want to look at the variables for this, and you'll see why. If you treated this like a distributive property, but going backwards, which you'll learn about later, you could go ahead and simplify this. You would still have your XMP. We could use order of operations here. 4 minus 2 is 2, and take that 2 and add it to the 6, and you'd get 8. So that would still be in my parentheses, indicating that I would multiply that by the XMP. So I would get 8XMP. So how could we get this a different way? Well, let's go back up here and look at the original problem for a second. Okay, I have 4 of these, take away 2 of these, plus 6 of these. Well, what's 4 take away 2 of those? Well, that would give me 2 of those, and it doesn't matter what order I list those variables. Now let's add 6 more of those, and I would get 8 of those. Same answer I got here. So why does the book take the time to show you this? Well, this is to prove to you mathematically that you can combine like terms. So to add the like terms, we algebraically add up the numerical coefficients. That's what we did. Or we could just drop it, let's say coefficients, like we talked about in a previous lesson. You don't have to show this part like they did in the book. You can do it just like I did here, where you just do the arithmetic and combine the ones that are like. So again, I wrote it out here. 4 of these, take away 2 of these would be 2 of these, plus 6 of those. And when we add those together, we get 8 of these. But it's important to understand that an XMP is the same as a PMX and the same as an MXP, so that you recognize that you can combine them.